Sweet. All right.
So I'd like to trim this. I've also got the Boss Road 10321. Okay, launching in 3, 2, 1. Hey, yeah.
Over the last maybe 2 decades, I've been flying kites, developing a technology of kite flying to measure very high resolution atmospheric variables up to a couple of kilometers in altitude. And that's in the last year or so morphed into using very small so-called UAVs. We have a nice platform, and what do we measure? What are we going to use this for? And basically we measure atmospheric pressures, temperatures, humidity, wind speed, and turbulence, and GPS location, obviously. All of these on time scales of seconds and spatial scales of very few meters. One of the main reasons for the stated existence of CIRES is to do interdisciplinary research. And this is, to me, a beautiful example. It's a natural marriage because of their technology. That's Professor Dale Lawrence. And he had already developed this aircraft and pretty well developed all of the software necessary to fly it autonomously. So we've put those two technologies together. The very small aircraft, which is called currently a CUMAV, it's a CU Micro Autonomous Vehicle. With our measurement capabilities, we put our instrumentation on the top. Where we're going is to fly arrays of maybe 5 to 10 CUMAVs from a single control center to provide essentially a 3D picture of the small-scale variability over a volume of, say, 2 kilometers on a side and 2 kilometers vertically.
Most of the vehicles and systems that are used now for atmospheric sensing are quite expensive. You have towers and blimps and various things. And the UAVs that people are starting to think of using are mostly, the military spin-off things that are really expensive. The standard one that a lot of people are using is $50,000 an airplane. And so crashing that really hurts. The thing I always come back to when talking about these is low cost. And that's one thing that's driven my research quite a bit. When we started doing this, the normal mode was we'd hand launch it and we would pilot it up with the RC piloting and then switch into some autonomous mode, which is convenient for testing, but for people that would want to use this, that requires someone with pilot skills. And so we were trying to get away from that, and we wanted to make it as autonomous as possible. So we looked into different kinds of launch techniques. One of those is a bungee launch, where we just put it on the small launcher and stretch a bungee. And the idea there is that someone could just load that and then step back and hit a button, and it would automatically launch and go fly. And so that would be something that really anybody could use. In discussions with Ben about some of the other applications, particularly the higher altitude ones, it wasn't clear that the plane itself could get up to high altitudes. So we talked about what else would we do. And one of those was drop from a balloon. And so that's where the balloon drop idea came from. And so there we loft the plane up on a balloon, and then once again we push a button to release it, and it goes into its autonomous flight after that. So those are the main ones we looked at so far. We're in the process of developing technology and at the same time trying to do science. And so, we're kind of just, one is going up and advancing one at a time, kind of in parallel with the other. A lot of the technology that we develop without a good application is kind of pointless. It's just technology for its own sake. From my point of view, having, the CIRES scientific interest combined with the engineering technology development, I get a lot out of that because it's a lot of direction for the work. And when it's all said and done, you really can look back and say we did something that made a difference.